morning children. In today's class we are proceeding with problems based on continuous random variable x, and the probability density function says small f of x, and what is cumulative distribution function capital F of x. All the formula connecting all the three. Let us recall. Small f of x is capital F dash of x. Differentiate capital F of x to get small f of x. Integrate small f of x to get capital F of x. What is capital F of x? Capital F of x is p of x less than or equal to x. So, if I want probability of x more than a, I can rewrite it as 1 minus probability of x less than or equal to a, and this idea is nothing but f of a. If I want probability between a and b, there are two methods. If small f is given, integrate between a and b. If capital F is known, f of upper limit minus f of lower limit. Let us proceed with the exercise problems. Question number 4, p.d.f of x is f of x equals k e power minus x by 3 for x greater than 0 and 0 for x less than or equal to 0. We need to find all this. Remember, whenever f of x is a p.d.f, f of x is greater than or equal to 0 and integral minus infinity to infinity f of x dx equals 1. In this problem, it is starting from 0 only. Below 0, it is 0. So, minus infinity to infinity is now becoming 0 to infinity k e power minus x by 3 dx, that is 1. Keep k out. Remember the formula e power ax. Whenever we integrate, it becomes e power ax by a. Here e power minus x by 3 is coming. As I integrate, e power minus x by 3 by minus 1 by 3. Between the limits 0 to infinity, that is 1. So we get k minus 1 by 3. When I reciprocate, it is minus 3. Apply the limits, e power minus x is infinity minus e power 0 equals to 1. Let us remember minus 3k into e power minus infinity, the value is 0, minus e power 0, the value is 1, and RHS is 1. That is minus into minus plus. 3k is 1 tells me k value 1 by 3. As we found out k, the second part is distribution function capital F of x is integral minus infinity to x f of x dx. In this question, we have the limits x below 0 and x is above 0. There are two cases, x below 0 and x is above 0. What is the formula? F of x is integral minus infinity to x f of x dx. Below 0, the function is 0. So, when I integrate 0, my answer is 0. The second part, when x is greater than 0, here they have given less than or equal to 0. When x is greater than 0, f of x is equal to integral minus infinity to x f of x dx. Where is x? Above 0. So how will I split it? Minus infinity to 0 because the function is above 0 only. So how will I split it? Minus infinity to 0, 0 to x. In minus infinity to 0, my answer is 0. So minus infinity to 0 is 0. 0 to x. Above 0, the function is k e power minus x by 3. What is k? It is 1 by 3 e power minus x by 3 dx. Integral 0 is 0. Forget it. Keep 1 by 3 as it is. What is e power minus x by 3 integral? Applying the formula, e power minus x by 3 divided by minus 1 by 3 between the limits 0 to x. Or capital F of x equals to 1 by 3 cancels, minus e power minus x by 3. The limits are from 0 to x. Put upper limit x minus e power minus x by 3. Lower limit minus symbol minus e power x value 0. Upper limit minus lower limit. Minus e power minus x by 3. Minus into minus is plus. E power 0 is 1. So we have got capital F of x is 0 when x is below 0 and 1 minus e power minus x by 3 when x is greater than 0. Let us tabulate. Third subdivision, p of x less than 3. P of x less than 3 is below 3. Whenever I want below, I can use cumulative distribution function. So p of x less than 3 can also be written as f of 3. 3 comes in this interval which is more than 0. Therefore substitute here 1 minus e power minus 3 by 3 or 1 minus e power minus 1 or 1 minus 1 by e cross multiplying e minus 1 by e. E power minus 1 can be written as 1 by e. Taking LCM e minus 1 by e, and that is the answer. Fourth subdivision, we want to find out p of 5 less than or equal to x. Rearranging by writing x first. X greater than or equal to 5. I say 5 less than or equal to x, or if I reverse, x greater than or equal to 5. My question is greater than or equal to. If I want to use capital F, I can write it as 1 minus p of x less than 5. Notice the idea. What I want is 5 or more. What I don't want is below 5. So whenever what I want is difficult to find, 1 minus what I don't want. So greater than or equal to 5 can also be written as 1 minus p of x less than 5. Why do we put 1? 1 is the total probability. What I want, what I don't want, if I add, I must get 1. Therefore, 1 minus p of x less than 5 can be written as f of 5. In continuous distribution, equal to comes or equal to does not come, it is one and the same. But in discrete, it matters a lot. Here, I can very well write f of 5. 1 minus. Where is 5 coming in this interval? Here. Wherever x comes, put 5. 1 minus e of minus 5 by 3. 1 and 1 cancels. Minus into minus plus. So my answer is e power minus 5 by 3. Fifth subdivision, we want to find out p of x less than or equal to 4. X less than or equal to 4, I can directly write f of 4. Substitute In this interval, here wherever x comes, put 4. 1 minus e power minus 4 by 3, and that is the answer. Question number 5. PDF of x is f of x, x plus 1 for x between minus 1 and 0, minus x plus 1 for x between 0 and 1 and 0 otherwise. Find the distribution function and p of minus 0.5 to 0.5. Distribution function, we denote capital F of x and the formula is p of x less than or equal to x. We read it as integral minus infinity to x f of x dx. Here, the limits are minus 1 to 0, 0 to 1. How will I split it? What happens if x is below minus 1? What happens if x is between minus 1 and 0? What happens if x is between 0 and 1? What happens if x is greater than 1? So the given problem, we split it as below minus 1, between minus 1 and 0, 0 and 1, and above 1. What is f of x in all these cases? Let us find out. F of x is equal to integral minus infinity to x. Where is x coming? Below minus 1. Below minus 1, the function is 0. If I integrate, my answer is also 0. Second part, when x is between minus 1 and 0, capital F of x is integral minus infinity to x f of x dx. This problem, I will split minus infinity to minus 1 plus minus 1 to x. Where is x coming? Between minus 1 and 0. So, minus infinity to minus 1, the function is 0. Minus 1 to x, minus 1 to, the function is x plus 1 dx. 0 when I integrate, it is 0. Integrate this one. X becomes x squared by 2 plus constant 1 becomes 1 into x. Between the limits minus 1 to x. Let me simplify. As I put x, it is x only. The lower limit minus. Put minus 1. Minus 1 square by 2 minus 1. Or x square by 2 plus x. 1 by 2, the symbol is minus. 1 by 2 minus 1. Or we get x square by 2 plus 6. Half minus 1 is minus half. Minus half into minus is plus half. And that is the function when x is between minus 1 and 0. The third interval, I have 0 to 1. We have 0 less than or equal to x less than 1. F of x is minus infinity to x, f of x dx. How should I split it? Minus infinity to minus 1, minus 1 to 0, 0 to x is coming here. So 0 to x. My question is 0 to 1, x is coming. How will I split it? Minus infinity to minus 1, minus 1 to 0, 0 to x. Minus infinity to minus 1 function is not defined, it is only 0. Minus 1 to 0. Minus 1 to 0, the function is x plus 1. 0 to x, 0 onwards, the function is minus x plus 1 dx. Now, f of x is equal to 0 plus x will become x square by 2 plus 1 will become x. Between the limits minus 1 to 0 plus Minus x becomes minus x square by 2 plus 1 becomes x between the limits 0 to x. Putting upper limit, it is 0. Putting lower limit, minus 1 square by 2 plus minus 1. So wherever x is coming, I put upper limit 0, my answer is 0. Lower limit minus 1, we have substituted. Plus, wherever x is coming, put x itself. Minus x square by 2 plus x. Minus, wherever x is coming, put lower limit 0, it is 0. As we simplify, f of x is equal to minus 1 if I square 1 by 2. Minus symbol here, minus 1 by 2. Minus of minus 1 plus 1 minus x square by 2 plus x. As we simplify, 1 minus half is half minus x square by 2 plus x. The last interval x is above 1. When x is above or equal to 1, how will I write it? F of x is equal to integral minus infinity to x, f of x dx. It is minus infinity to minus 1, minus 1 to 0, 0 to plus 1 and 1 to x. Where is x coming? After 1. So how will I split it? Minus infinity to minus 1, minus 1 to 0, 0 to 1, 1 to x. Minus infinity to minus 1, it is 0. Minus 1 to 0, it is x plus 1. 0 to 1, it is minus x plus 1. 1 to x, after 1, it is 0. If I simplify, this is 0, this is also 0. So only this part is left out. X becomes x square by 2 plus x between the limits minus 1 to 0 plus this becomes minus x square by 2 plus x between the limits 0 to 1. As I simplify, f of x is equal to, when I put 0, it is 0 plus wherever x is coming, put minus 1. Minus 1 square, 1 by 2. Minus 1. This is lower limit, so put minus symbol. Plus, put upper limit. Minus 1 by 2 plus 1. Put lower limit, it is 0. As I simplify, it is minus half plus 1 minus half plus 1. Minus half is minus 1. Minus 1 plus 1 is cancelled. We are left with 1. So capital F of x is 0 when x is below minus 1. Between minus 1 and 0, my answer is x square by 2 plus x plus half. Between 0 and 1, it is half minus x square by 2 plus x. Above 1, my answer is 1. As we tabulate, f of x is 0 when x is less than minus 1, x square by 2 plus x plus 1 by 2. When x is between minus 1 and 0, minus x square by 2 plus x plus 1 by 2. When x is between 0 and 1 if x is greater than or equal to 1. Thus, we have solved the problem. The second part of the question is, I want to find p of minus 0.5 less than or equal to x less than or equal to 0.5. How to find it? When I want probability of a less than or equal to x less than or equal to b, my formula is f of b minus f of a. Capital F of b minus capital F of a. Using that, I am able to prove here capital F of 0.5 minus capital F of minus 0.5. What is capital F of 0.5? Out of the intervals, check where 0.5 falls. 0.5 falls here. So, wherever x is coming, put 0.5 minus 0.5 square by 2 plus 0.5 plus half. Minus. Where is minus 0.5 falling? Minus 0.5 will be here. So, substitute in this. Minus 0.5 the whole square by 2 plus minus 0.5 plus 1 by 2. As we simplify the answer, minus 0.25 by 2 plus 0.5 plus 1 by 2 minus 0.25 by 2 minus into minus plus 0.5 minus into half minus half. Plus half minus half is getting cancelled. Taking LCM 2, it is minus 0.25 plus 2 into 0.5 1 minus 0.25 plus 2 into 0.5 1. 1 plus 1 2. 2 minus 0.25 minus 0.25 gives me 1.5 divided by 2. And my answer is 0.75. So, using the idea of capital F of x, I can find it like this. The same problem, another method. Integrate small f of x between minus 0.5 and plus 0.5. So, you can either try using capital F of x or P of a to b is integral a to b small f of x. So, instead of using integral upper limit, lower limit, this idea will be easier. Question number 6. If x is a random variable with a distribution function capital F of x equals 0 when x is less than 0, half x square plus x when x is between 0 and 1 when x is greater than or equal to 1. How to get the p.d.f. and probability of x between two values? Probability density function small f of x equals to capital F dash of x, that is differentiate capital F of x to get small f of x. So the same intervals we have written. What is p.d.f? Let us differentiate. 0. When I differentiate, it is 0. Half x square plus x. X square becomes 2x. X becomes 1. I am differentiating. X square becomes 2x. X becomes 1. When x is more than or equal to 1, 1 is coming. Differentiating 1, which is a constant, it will become 0. As I see, below 0 and above 1, my answer is 0. So the function is defined in 0 to 1 interval. The remaining places it is found to be 0. So rewriting f of x equal to half into 2x plus 1. Cancel 2 and 2. It is x plus 1 by 2. When x is between 0 and 1. It is 0 in all the other places. So the first part of the question is over. Second part, P of 0.3 less than or equal to x less than or equal to 0.6. Let us remember the formula. P of a to b is nothing but f of b minus f of a. In this question, b is 0.6 and a is 0.3. F of 0.6 minus f of 0.3. Check in capital F of x where 0.6 is coming. So 0.6 falls here. What is my answer? Half Wherever x is coming, put 0.6. 0.6 the whole square plus 0.6 minus. Where is 0.3 coming? Here again. So wherever x is coming, put 0.3. Half into 0.3 the whole square plus 0.3. As we simplify in both the cases, half is common. 0.6 square is 0.36 plus 0.6 minus 0.09 minus 0.3. As we simplify, our answer is half into 0.96 minus 0.39 reducing to 0.285, and that is the answer. So whenever we are given P of A to B, there are two methods. Integral A to B small f of x dx or capital F of B minus capital F of A. So whichever method you prefer, you can do it.